The following experiment will demonstrate that what we perceive as curvature of the Earth due to its spherical surface may actually be atmospheric phenomena occurring over a horizontal surface. This experiment can be conducted on various level surfaces, both indoor and outdoor, basketball courts, tennis courts, ice rinks, and so on. It can even be conducted over small ponds and bodies of water. These observations show that a spherical surface is not necessary in order to witness objects disappearing from view bottom up. Theoretical curvature cannot be pointed to as the cause for the apparent sinking in the experiments presented here, as these observations all take place within 600 feet. Which is not enough distance for any of the said curvature to be present at all. We will also demonstrate that, from a distance, the bottom floors or layers of buildings and structures also disappear because of atmosphere over a horizontal surface, not disappearing behind a curved one. We will be using a scale of 1 inch equal to 5 feet. Our viewer height will be 1.5 inches, so 7.5 feet to scale. These observations are being made over small ponds, which produce small waves, accurately simulating the waves seen when boats sail on the ocean in large water. A wave of about an inch or so on our experimental ponds would represent an ocean wave of approximately 5 feet. This first observation was made on July 24th, and the temperature was around 82 degrees at the start of the experiment. The blue toy boat represents a boat that's approximately 30 feet long by 8 feet tall. The yellow and orange boat represents a vessel that would be 25 feet long and 15 feet tall. During the hottest parts of the day, the boats disappear hull first while moving away from the viewer and camera, but they do so above the apparent horizon. This is to be expected due to the variation in temperature of the air and the temperature of the water. As the evening presses on, the temperature in the air cools down, and the boats begin to disappear hull first at or below the apparent horizon. Next, we'll see objects that are set up across the pond to represent a distant city skyline. Like the larger buildings and structures whose bottom layers are no longer visible, seeming to be sunken below the ocean horizon, these objects will also be missing their bottom layers. This rough miniature skyline is placed approximately 550 feet away from the viewer or camera, which is 6 1/4 miles away to scale. With the viewer height of 1.5 inches or 7.5 feet, we can expect to be missing just over an inch from the bottom of the skyline objects, representative of about 5.5 feet. Notice how when we view the skyline from a higher vantage point, all of the objects are in view. But when we go down to the water surface, most of the objects are no longer visible. Reminder, we are not merely seeing these objects from a higher view because we are raising above a curve, and they are not disappearing behind a curve when we drop our view. This pond is too small for that to be the case. Notice the dramatic disappearance at the bottom of the objects after just a slight change in viewer height. This observation takes place in 27-degree temperatures and will include another toy boat and representative city skyline, this time with the boat sailing to the skyline objects. On this day, the cold air above the warmer water causes miraging and lots of atmospheric distortion as the boat sails off.
Okay, you got to check out Sky Freeze channel. They only got like 20 subscribers. It means a whole lot more. But what I wanted to do is take their scaled down version and see if I could match it to one of my live observations of boats going out into this mirroring zone, and see how well I could compare it and see how well it showed up or compared to it. And it to me, this really does explain a lot of reasons why the bottom of holes, the bottoms of buildings all vanish across the horizon, because anything that's within this mirroring zone gets cut off. It just blends into its own reflected image and vanishes into infinity, into the vanishing zone. And when you have heavy mirroring, this vanishing zone, or these boats will vanish at a much closer distance than if it was on a day of good visibility. Day of good visibility, I not only see these boats going out, over 3 miles, but I see them going out 7, 8, 9 miles, and that's even from a very low perspective of about 28 inches. Now, as this boat gets out here to the Bayport rack, Bayport is 3.5 miles approximately, and you'll see this boat start turning and changing its angles. Well, you've pretty much seen some angle changes already through this run, but he'll change his angles, which also gives this boat a different appearance. When it turns side to the side and you get the profile, you can see more of the boat, of course, and then when he turns back at you, he comes straight at you, you see a different profile of it. This time, this is why I picked this footage out, because this guy was going back and forth, turning around, then he comes back and goes over his own wakes, and you can see how the boat bobbed up and down because he hit his own wakes, but his wakes were invisible. You could not see them. Why? Because it's in this invisible water. This is water out here, folks, that this boat is in, but it just has some optical effects that gives you this illusion of a curve. So again, my height compared to theirs, I'm pretty sure they said they were 7 to 8 feet. I'm figuring I'm about 7 to 8 feet myself here. I'm low to the seawall. My tripod is not set up all the way, and I slowed this part back down. The other part was sped up 3 times the speed. But as you see here, obviously my tripod ain't real high. It's probably set at about 28 inches or a little bit above. I know I have it probably set on the lowest setting because I like to sit down on the seawall and do my filming sometimes if I didn't bring my chair. But obviously, too, you can see how this whole skyline is just mirrored into the water all the way out until the vanishing point, until everything blends into its own reflection. And then if these clouds were moving away, you would just see them vanishing into their own reflection in the water. And I do have some time lapses that show that how these clouds are vanishing. Maybe I'll add them into one of my other videos in the future. But please subscribe to Sky Freeze channel. I'll put a link in the description. I'll put a link in the comments section too, so you can find their channel. They've done some really, really nice small scale tests, and you can judge for yourself. Also, it gives you a good idea of how to do these tests yourself, which we always suggest that people do. All right, thanks for watching.